Hi everyone, welcome to day 7. So today we are going to talk a little more additional functions in RDD. So we have even more functions which we can talk RDD, but before that we need to understand what is partitioning, what is node, and all these things. So in today's session I'm trying to keep it brief and covering couple of additional functions which does not require discussion of partitions. And in next class I'm going to give you a full theory session that is talking about what is partition, how it is working. We talked about different terms, right, in previous sessions. So we'll be covering those things and clarifying like what is partition. Then we'll go to additional functions like calls and all these things in the upcoming sessions after the theory class. Moving on to the database screen, I have already my cluster running to have this code written. So we have covered until map yesterday. So we have this flatMap function. So like if you wanted to split it, right, as a single result, as you're seeing, I'll run it once again. If you wanted to split it as a single result, however it is multiple, so you can use flatMap. So let us see what it returned instead of flatMap if you are giving it as map, right? So that like you can practically experience where map can play a role instead of flatMap. So keep this result in mind, and I'm running this map. You can see this hello world is given as one group, and like data bricks rocks is another group, but in flat map everything is coming in a single group. So that's the difference between flat map and map. So talking about yeah, map we have already covered, but however I can take it like since I have this code here. I'm creating a data set with this Alice, Bob, Alice, and I'm running this. So here you can see map is helping me to add a specific value. I have added 5, age 5 to all the records. Now let us use the same dataset. So our dataset name is RDD. I am going to use the same dataset RDD for our distinct function. So what is distinct? So you have learned that distinct in SQL, right? So if you wanted to remove the duplicate from a result set, you use distincts. So here for us, like we have to consider each tuple, that is nothing but whatever comes under in one bracket like a row. So here I have these values like Alice 32, Alice 32, that need to be considered as duplicate, and I am running my distinct. So I have two ways: either I can assign these to a different RDD, or I can directly use collect to show it. So here it is showing only 3 values, right? Sorry, 3 tuples, because this API is giving me like result which is not duplicated. I had this Alice twice, so it is removed automatically using the distinct function, right? So moving on to the next one, which is union. Union work as similar as how we have union in SQL. If you have a data set, you already have an RDD and you wanted to combine another RDD along with that. So here we are using the same one. We are creating a new RDD called RDD extra, which is having a tuple David, and we had our old RDD, this RDD, and we are unioning that. You can see RDD and you have this API union, and we are passing the parameter as that another union inside that API, and you will be getting the result which combines both. So like we had this Alice, Bob, Charles and Alice, and you are combining that with this David, which is giving a combined result. Maybe if you have a confusion why like ILs twice, there were two ILs in my RDD dataset. Here I haven't made any changes. I just showed you the result. The RDD remains same as with the for like duplicate ILs. Okay. So now I hope you are clear about what is union. Now let us move on to intersection. So intersection is nothing but a combination of two sets. You have like union, intersect, except all these things. So we are like covering the same thing here. Union we covered. We have intersection. Intersection will help you to get only the result which is in common. So here I have 4, 5 in common in both the cases. So if I ran my query, or yeah, so this is going to give me only 4 comma 5, only matching values will give, right? Now moving on to the subtract is same as except. So whatever is this in RDD A, it provides the result which is there in RDD A but not in RDD B. So here 1 2 3 is not there in the other set, so it is showing like 1 2 3 as a result, right? So Cartesian RDD is nothing but the combination, like it does that cross join. You can relate that to cross join, right? I'm doing the Cartesian A and B, so it's creating tuples with all the combination which is available, right? 1 4 1 5 1 6, all the combination which is creating this key value pair tuples, that is having the combination of everything. That is where the how Cartesian works. So I have like two more things to cover. That's one is about sort by key. So when you use this tuple with two values, right, we can consider them as key value pair. The first one is key, second one is value. So if you wanted to sort your result based on this key, you can use sort by key function. This will always take your first value, and this works only when you have a key value pair. If in case if you have like 3 values in a tuple, this sort by key is not going to work. In that case, if you wanted to sort a result, you got to use sort by API. That like here what you are doing, you are saying I wanted to sort it, which column you are saying like based on the index, right? X1 refers this second value because 0 is the first value and 1 is second value. And you can also say ascending or descending by setting ascending is false. So I'll run this for you. You can see the value with 110 is coming first and second this 40 is coming. You might have a doubt like, okay, it's because of this. No, I'm running this once again. So in the other case, AAVD should have been come second, right, when you give descending. So this is purely working based on the first position, that is this one. Okay, so these are two things, like keep in mind, sort by key and sort by. And I'll conclude this video with the reduce function. So reduce will it's kind of a grouping and aggregating. So here you will be combining all this result and giving you single value. So if you run this, you can see you are getting 15. 15 is the sum of all these values. So it's not giving you an RDD, it is more of giving you an integer result set. Okay, if you wanted to take sum of values or things like that, right, you will be using, it's not a group by, but when you combine. So what map was doing, map was helping you to apply one function or like one particular logic on top of all the rows or like all the tuples. So here reduce is going to aggregate and giving you the result. That is where the difference between map and reduce coming into picture. I know I was going little fast because these APIs and all these things, I was keep using function, but you should use the word API. These APIs, all these things you will be able to easily cover, but I just wanted to quickly run it through and show you what it is. And tomorrow's, so I was restricted to most of this basic functionality because I haven't talked about what is parallelism, what is node, how the cluster is working, Spark cluster, right? Because all these what we have covered until now in all these 7 classes, or like maybe mainly talking about RDD and data frame, right? All these functionalities can be done by any of this Python, right? If you take pandas or anything, you can do most of these things. So how Spark is unique, or like what is this clustering, what is this nodes? So that is what the nodes and parallel processing keep this PySpark unique from other like data operations. So in order to understand and group, like go deep dive into that, right? You got to understand what is node, what is parallel processing, how it is working. This like not so interesting coding, but more of a theory part, which we are going to cover in like upcoming class. So that like from there we'll be able to take off into more like deep dive into the functionalities, which will help you to understand how this parallel processing working, and all these more detail into like lazy evaluation, calls. I was talking about some functions, right? We can start exploring those functions. So this is all for today, and we'll be moving into the theory class of node, Spark clusters, and all these things tomorrow. So hope you enjoy this video, and if you have any questions, please add it in comment. Thank you for watching.